switch in this machine, but this is another one, is an OR gate, which means that the signal would pass if that switch or that switch is switched on. Well, there are 500 or 600 switches in this machine to make it work. It's a beautiful mechanism. It actually still works, and the owners are looking for a good home for it because it's been replaced by this. The central processing unit from the micro they're now using, and unbelievably, it's got several thousand of those gates in it. Well, imagine yourself inside a microcomputer. You see arrays of chips and other rather mysterious-looking components. But where does the program from the cassette tape go when we run it into the computer? Remember the stream of musical notes, either high or low, correspond to our ons and offs. We call this a bit stream. Each of the beeps represents one bit of information. And because each bit follows the one before, it's called a serial bit stream. Now, somewhere over there is an area of the computer whose job it is to communicate with the outside world. There are inputs from cassette, disc, joysticks and so on, and chips to process the information received. The musical notes are converted into simple electrical ons and offs. This stream of bits then goes into another chip where it's packaged into chunks of 8, something like this. Each chunk of 8 bits is called a byte, and the program then travels 1 byte at a time as a parallel bit stream along 8 wires known as a bus into this thing that I'm sitting on. This is the main chip, if you like, the microprocessor, the central processing unit, or CPU for short. Now, because the CPU can handle 8 bits in parallel at once, it's called an 8-bit micro. Other CPUs can handle 16 or even 32 bits, but most personal micros are 8-bit machines. The CPU then sends bytes of our program one at a time to part of the computer's memory. Well, this is a representation of it. There's a byte of memory. Each of these has an address so that the CPU can find information that it wants later on. The byte stream goes into the CPU, then the byte is transferred in parallel, one at a time, into memory. Just imagine if one of these bits gets in the wrong place, the chances of a program working is very, very slim. Now, this CPU can use about 64,000 bytes of memory at any one time, or in computer jargon, 64K. But only some of that is available to hold our program or information typed in from the keyboard. This is the working memory space of the computer. These chips hold 16K of working memory. That's over 16,000 bytes of information. And you can add more by plugging in more chips right here in front of me, up to a maximum of 32K. That enables you to handle bigger programs, more information, or better graphics on the screen. It's called random access memory, or RAM for short. And on this particular machine, it's volatile, which means that if you switch the machine off and you switch it on again, you lose all the information and the programs you've got in your memory at that time, and you've got to input them once again. Well, this isn't the only memory in the computer. You remember, this is an 8-bit machine, and it can have up to 64K of memory. Well, these chips over here also form part of the memory, but these contain programs which are permanently burnt into them. This one here contains instructions for the language which the computer understands, in this case, BASIC. And this one over here contains what's called the machine operating system. It's the program that does the housekeeping inside the computer itself, how the computer makes letters appear on the screen, and how it knows what key I'm pressing when I'm using the keyboard. Now, unlike a program held in RAM where the information is volatile, this kind of program doesn't disappear when the power's switched off. There's a representation of memory. If I switch the machine off, then on again, the exact same representation is there. It's what's known as read-only memory, or ROM for short. Well, over here, there's also some empty sockets where you can plug in chips which have a variety of other programs burnt onto them. For example, a word processing program, or even a different language like Pascal. Well, we've only had time to look at the most important chips in this micro. There are many others concerned with linking the machine with all kinds of different input-output devices from the outside world. Now, let's see how I get out of here. How about that? Well, we've seen some of the things you can attach to the computer, and here are a few others which we'll be looking at in the course of the series. Now, in a similar way to the way we stored our script and then printed it out on a printer, so we can store a design in the memory of the computer. And here we've got a design of a house in the memory of a computer, and we're rotating it around almost as if we're circling the house in a helicopter. It would be possible to change either the program or the data to change this if you didn't like a particular view. Now, if we wanted to print that out, a normal printer really would be rather unsatisfactory. So we use this device, which is a two-dimensional plotter. We can hit the key and away it goes. Now, it prints it with a pen there of one colour. It's a black pen that we happen to have in at the moment. At the side, there are other pens, red, green, and blue, and so on. And it can interchange those pens to give a sort of multicolour effect on this line plot. And it's quite a high quality. The plot is an expensive piece of gear, and it costs about £5,000. It plugs straight into the computer at the back, and there's a special software to drive it. Well, here's a more modest setup which makes use of yet further connections to the machine, opens up another avenue of interest. What's happening is my voice is being picked up by the microphone, fed through some electronic gadgetry, and then the computer analyses it and feeds it back here. We get this trace here, and the man even opens his mouth. Ha, ha, ha. We have another device here which can also input information into the computer, and I'll read another program in from disk, and there we have a representation of a weighing machine, and on the side the same information displayed digitally. All I have to do is to press this pad. You are 31 pounds, it reads it off there, and on the weighing machine it moves. Not only can it do that, but it can actually weigh me. I simply have to print on this. Of course, it's a rather cheap piece of gear, this, and it's very inaccurate, but it'll give some representation of what you are, 205 pounds. Not only will it read it out digitally, but I simply press a button, and, with a bit of luck...
You are 205 pounds.
And need to lose some weight. Well, in later programs, we'll look in more detail at how we can use it for displaying graphics, making music, controlling equipment, and handling words. Well, amongst many other things, we'll be talking to the computer and getting it to talk to us, and looking at how it can monitor what's happening in the world around it. Next time, we start looking at how you can write your own programs. Until then, goodbye.